And so our next speaker is Herbert. He is at the Technical University of Munich, and he's going to be talking to us about some collaborative work he's been recently diving into as a result of the EU AI Act starting to take shape. And in the process of working on this project, it actually went through a couple of revisions, and we sort of got to understand exactly what it was trying to go after a little bit more precisely, although it does look like it'll take quite some time before we fully understand how it's going to be kind of implemented and interpreted and so on, which is part of the exercise he was looking at. Um, over to you, Herbert. It's been wonderful looking at this topic actually with you.
Great, thanks, Nick. I think, yeah, perfect. So hope you can see my screen and hear me well.
Yeah, we can hear you. We can see your slides.
Perfect. Okay. Yeah. So, yeah, thanks for having me, Nick and Daniel. I'm really excited to be talking about our most recent work on federated learning priorities under the EU AI Act. This is joint work with Alex, Bill, Shiqiang, Nick, Ruben, and Arno. And you see there are quite a few institutions involved. So we really tried to take a broad look on this topic. So this talk is organized along four major points. So first of all, I'll briefly give an overview of the AI Act itself, how it's organized, and what we as researchers and also sort of technical practitioners can expect from it. Then secondly, I will go deeper into what does this new regulation mean for federated learning, at least in how it's available, or how the regulation is available at the moment. Then the third part will be about the three cornerstones that sort of concern federated learning and what sort of new research priorities we can derive from that. And lastly, a brief stint into what other regulations are coming our way in different regions and countries. So with regard to the EU AI Act, it's organized based on a risk-based assessment. And with the latest revision that has become available end of January, there's now also a section on general purpose AI. So general purpose AI generally sort of contain everything that has to do with foundation models, and models that use training above a total training load of 10 to the power of 26 floating point operations. But in this talk, I will mainly focus on the risk-based assessment as it was sort of initially introduced back in 2022, which has four categories. So the top level is unacceptable risk, meaning applications that are sort of illegal to provide. This, for instance, refers to biometric applications with some very strict exceptions for governments. Then the second sort of tranche in the pyramid is high-risk applications that pertain to medical devices and also things like job application pre-screening. So whenever you sort of apply for a job and something automatically selects applications, this also falls under the high-risk regime here. Then we also have limited applications, which are, for instance, chatbots like ChatGPT, and minimal risk applications that are highly specialized models, for instance, for decision support systems in corporates. So as federated learning is originally designed for private and very sensitive data applications, in this talk, I will focus on the high-risk tranche here that asks us to develop extensive quality management techniques, whether it's for federated learning or any other AI application, doesn't matter here. But as said, federated learning is specifically made for those sort of very sensitive use cases. And the objective within the high-risk category is really to develop trustworthy AI applications. And in case of federated learning, we see three major assessment criteria here. So number one is data governance, number two, energy efficiency, and robustness. And all three of them bring new challenges to the field of federated learning. So let me start with data governance. And this is probably mostly found in FL ops applications right now. But the EU AI Act sets out very strict and extensive regulation in case of high-risk applications here. So the objective of data governance is to mitigate bias that originates from data and also prioritizes privacy in form of GDPR. So bias prevention, as it's stated in the EU AI Act, is really a matter of appropriate data pre-processing. What appropriate means is depending, obviously, on the task itself, and fairness considerations. Both things are very challenging in federated learning to achieve, since we are not able to really see input data and interact with the input data apart from feeding it into the local models at the clients. But what's noteworthy here is, in terms of fairness, there has been quite some progress in federated learning with works like Q-FAIR federated averaging, for instance, that try to have or create very representative models across all clients. And the second big piece is GDPR. I mean, everybody who's read a federated learning paper may have stumbled across the word GDPR and privacy regulation. But what does this mean specifically for us? So GDPR sets out 3 points that we need to address when working with federated learning. So number one is security while processing data. This means we have to make sure that data is only used sort of in the way it's intended to be, and we really minimize risks of data leakage. The second part is the right to information. Which means that whenever we have a client provide data to us as service providers, they can always ask, has my data been used and how has my data been used? So for federated learning, this is at the moment a challenging question to answer. We either have to keep track of what clients have participated in training, or have some way of identifying what data has flown into our global model, which again, is almost impossible to do. But nonetheless, this requirement will become very important for anybody doing federated learning. And the last point is consent-based data processing. So this means whenever we have a application, users give their specific consent to us processing their data. But once they revoke this consent, we immediately have to remove that data. And this calls for model unlearning, which is a very hot topic in machine learning in general. And there is first progress in federated learning as well by some people at IBM Research to really look into how can we unlearn models in a federated setting, such that we can, in case of GDPR, provide compliance here. Second big sort of element here is then energy efficiency, that really calls for sustainable training and deployment methods. And in case of federated learning, what's really interesting here is we might see new benchmarks coming up, because the EU AI Act or in the scope of the EU AI Act, the European Union has established an AI office. So basically the interface between sort of regulators, practitioners, and researchers. And they are calling for common baselines and KPIs that should define how we do machine learning or deep learning. And for federated learning, we have to come up with those baselines and meaningful KPIs that resemble those baselines. The second part within energy efficiency is we also have to account for the total energy incurred in a federated learning system. What this means, I'll come to in just a brief moment. And last one, and a very important point, is that with the privacy methods we currently have available for federated learning, right? So, and I'm referring to technical privacy, they all come with a certain overhead. So what we will likely experience is a natural trade-off between privacy and energy efficiency. And the last sort of big building block is then robustness, which refers to consistent model performance. I mean, this has been a focus in federated learning for a very long time. But now we have to look into how do we ensure model quality? And this is interlinked with data governance as well, by using certain reference data sets. They are not created yet, so they have to be established, have to come from researchers and practitioners, but this will be a priority inside the AI. Then what's also important, and this will be very important for those technical privacy techniques that we have in federated learning, is model validation or inspection. So what we generally see is validating models on clients can be very challenging, right? So we can have validation strategies run on clients, but in light of the EU AI Act with those reference data sets, this can become a challenging effort. So to sum it up, the EU AI Act will put a lot of, especially data governance regulation on us, but this will help us improve the quality of federated learning systems, I believe. And overall, if we don't comply with the AI Act, this can cost up to 35 million euros or 7% of gross global revenue, whatever is higher. So we see there's substantial financial sort of penalties if we don't comply. So, but let's now take a deeper look into each of those pillars and understand what this means for federated learning in detail. So in terms of data governance, whenever you read a federated learning paper, you usually find at least a sentence about GDPR compliance of federated learning. What we asked ourselves is this really true? Do we have full GDPR compliance with federated learning as it stands right now? And the question is really, really hard to answer because what we have to distinguish between is technical privacy, so in form of, for instance, differential privacy, secure multi-party computation, and homomorphic encryption, and regulatory privacy, which is this enforced by law itself. And what we find is that this is an unsolved challenge or unsolved problem. And on top of that, we also see that a technique like differential privacy works very well in scaled systems and provides technical privacy or tight technical privacy guarantees, as can be seen in works by Andrew et al. Or McMahon. But for smaller systems, say we want to fine-tune a transformer model with for email classification, as you would, for instance, see it in job pre-screening applications, we see that achieving tight privacy guarantees comes at significant costs, right? So this is depicted here, and these substantial costs mean nothing else than increased energy consumption to achieve a certain training target. And also, as I said, there is a gap between technical privacy, especially in the case of differential privacy, and regulatory privacy. For the cryptographic methods, SMPC and homomorphic encryption, they provide secure computation, and secure multi-party computation allows us to compute global models from encrypted client updates, but comes at significant communication costs. So we have a quadratic communication cost component, which means scaling is rather expensive. And also, if we remember from the requirements set out by the EU AI Act, this whole point of model validation and model inspection is very important to be legally compliant. So this is possible with SMPC and differential privacy alike. But for homomorphic encryption, the situation is currently a little different. Here, the server itself must never see the global model. And as such, the validation of a model is challenging to achieve right now. But again, if we emphasize research or put in research efforts, we can potentially find model validation strategies that work with homomorphic encryption as well. What's also very interesting is that when we sort of downscale a federated learning system with differential privacy, we exhibit those costs. And whenever we scale up a secure multi-party computation system, we exhibit additional communication costs. So we see a privacy and energy trade-off in each of these approaches, but also an open question: what is the right privacy or security technique to choose for a certain system? So this is it about data governance. Now let's look into energy efficiency. And for energy efficiency, I earlier said it's about total cost in a federated learning system. And what we've been looking at was a very conservative approach here that really takes into account every single piece that is involved in a federated learning setup. So what we can do is we can measure the compute power, or the sort of the energy used for compute on the clients and the server directly. So as we can either request this as metadata or measure it in real time. But what's very challenging to measure is the cost of communication. Luckily for that, in 2015, Vishwanath et al. Introduced the per bit communication cost model that allows us to really trace how much energy a certain bit that we communicate consumes while traveling along the communication chain. What's, however, noteworthy here is that to effectively use the per bit communication cost model, we must know the energy characteristics of every hop we take, right? So we can, with, for instance, trace routes, the trace route library, we can trace whatever hop we take, but we also need to know how much energy is consumed per bit. So this is still a limitation that's open, but could become relevant to solve in light of the EU AI. And lastly, we have robustness, which is very closely tied to energy efficiency. Why is that? So federated learning as such is a data parallel processing paradigm. And this means whenever we train on multiple clients in parallel, and then we validate our model before starting into the next training round, or we validate in a certain frequency. So what we've done here is, in this experiment for fine-tuning a BERT transformer for email classification, we validate every 20 rounds with a total training time of 2,000 federated learning rounds. And what we see is, to achieve a target accuracy of 50%, we take longer in terms of time, but also we consume significantly more energy. Why is that? So for compute, obviously, we're computing data parallel. So there's more computation involved than centralized on a single machine. But also we have this idle time here. And this idle time is basically time the system sort of sits idle while validation of the model is happening. And we are, as said, we are validating every 20 aggregation rounds. And in general, this can really pose a challenge when it comes to energy efficient federated learning. For this, we were thinking of techniques to perform validation in a certain frequency, right? So we really risk those idle times for potentially being providing a more robust model. Or we do, for instance, asynchronous validation at the risk of running into a less robust model and having to redo a few steps. So again, this is an open question, but this can become very relevant under the EU AI Act. And also what is noteworthy and special to the EU is the structure of energy cost. And this is why we really think energy is an important component in federated learning. So what we see is the generation and taxes of a single kilowatt hour of energy are declining. But in 2026, the European Union intends to introduce a market-made price for CO2 certificates. So, and experts now estimate that in the best case, we pay 65 euros per metric ton of CO2, and in the worst case, up to 300 euros. So this means whatever we save here in terms of the gross energy price we can pay extra in terms of CO2 if we all emit a lot of CO2 by 2026. So overall, this underpins why energy is such an important component in federated learning. So now that I've outlined a lot of challenges that federated learning faces in the EU AI Act, let's look at some qualitative benefits that federated learning brings in by design. So federated learning, as we move models to the client, we get access to siloed data, right? So there's no need to move data from A to B. And this can really help us break open data silos and also account for this whole point of reducing data bias as we have a broader database basis to train our models on. The second point is simple data lineage. This is a requirement introduced by GDPR. So us as service providers, whether it's open source or commercial, we have to keep track of where is data used and where do we have potential data leakage risks. And in federated learning, input data can only be leaked at the client as we're not moving data. And this is obviously only given if we employ secure and private computation techniques in an appropriate manner that is, as said earlier, yet to be defined. And lastly, low bias models. Why low bias models? So federated learning can enable continuous learning. And this means we can adapt on the fly to our client bases and really learn what clients or what data clients have available for us. And with that, the system automatically adjusts to the needs of clients that will eventually use the model for inference purposes. So now that we know about the challenges in depth and qualitative benefits, we think there are especially 4 points that need to be addressed for federated learning to become AI compliant. So first and foremost, we have to close the gap between regulatory and technical privacy. Then we also have to look into CO2-based regularization of federated learning methods. So similar to as what we've done with using the number of samples processed on a client to create a weighted average, we could also look into how we can use CO2 as a regularization criterion to establish green federated learning systems. Third point is establishing technical frameworks that enable AI compliance. So if we want to drive the adoption of federated learning on a broad basis, we have to make sure that people who really apply federated learning get a tool set which they can use to determine the appropriate measures for AI compliance. And last but not least, the comprehensive baselines for federated learning. This entails both technical, like full federated learning pipelines that measure relevant KPIs that are also yet to be determined, and also reference data sets that we can use to evaluate the quality of models produced in federated learning systems. So this closes the part between the EU AI Act and federated learning. Now let's take a final look on what else is coming our way. So there's other countries that prepare AI regulation similar to what the EU has done. So in the US, there's the White House Executive Order on AI that was released in October 2023. And they are establishing guardrails for AI applications based on the total compute used in training. So for instance, for general purpose AI, they also set out a threshold of 10 to the power of 26 floating point operations to, as sort of a categorization for machine learning models. And what is also very interesting is this executive order contains a call for a research agenda to explore the regulatory compliance of differential privacy to really evaluate how can we close the gap or can we even close the gap. And in Canada, we see Bill C-27. They set out their priority to align with international AI laws, so whatever is established in the EU, and in the US. And they also mentioned the EU AI Act as a lighthouse regulatory framework, which they see as a convergence target for themselves. So we see there's a lot of movement going on right now. And we definitely have to act in order to really keep the practicality of federated learning going forward. So with that, I conclude my talk, and I once more thank the amazing people I got to work with on this piece. Yeah, that's it. Thank you.
Thank you so much. I think it's really interesting and really kind of timely um, period for federated learning. So we can start to see how some of the benefits that have been around since its inception, I think are really going to start to crystallize as we see people understand how they should regulate AI more seriously. And I think what this work is showing us is that many of the pieces are already in place, although there are certainly quite a few bridges to be crossed. But that is true actually of all the other learning approaches too. I'm sure they have other bridges I need to cross to be compliant. Um, let's see if there's any questions from folks. I'll scout around on the Slack, and if anyone here live in the room wants to ask a question, just raise your hand. Could be a comment as well, of course, not just a question. While I look
Maybe a
around.
super quick question from my side. First of all, thanks. A super interesting talk and great summary of what is happening and how it relates to AI and federated learning. I'm wondering, apart from regulations in the US and in Canada, are you aware of other similar regulations around the globe that are being thought about maybe or already proposed?
So I'm not aware of any other specifically, but if it develops a similar dynamic to GDPR, I wouldn't be surprised that something's coming up within the next couple of months in other regions as well.
So, Daniel, did you have any other follow-up questions to that, or?
No, thanks.
Okay, just checking. We have a question here. They're asking, where do you think, well, I guess they're trying to say, given this situation with the Act and how federal learning needs to evolve to meet some of these needs, um, once it makes those bridges, where do you think it'll be applied to? Kind of what sort of opportunities arise in different application spaces, do you think?
Yeah, so as I said initially, going back to this slide, I think federated learning is meant for high-risk application, right? So anything that involves sensitive data and that really requires to be rigid on quality. Yeah, so this involves medical devices. So I'm currently working with an industry partner on medical imaging. And they are exploring this for multiple of their MRI machines. So they have different generations. Yeah, so this is where I currently see federated learning going.
Another question here is about energy and how there seems to be many, I guess, from what you said here, there's a lot of unanswered questions about how we exactly should measure energy and compare it to other approaches. So the question was, what do you think is the fair way to measure energy used by different, quite substantially different ways of doing learning? Centralized, you might have completely just entirely locally, there's federated and so forth. What do you believe is the right way to account for the different factors that get it consumed during those processes?
Yeah, so that's a very good question. Thanks to the person bringing that up. As I said during the talk, I think for those comprehensive baselines, taking a conservative approach is the best way to go. That's my personal opinion. But again, what we have here is a challenging situation of network providers making the data available, like in terms of whatever power we consume per bit, for a federated learning service provider, for instance, to calculate those costs, right? So I think this will be a trade-off between really being thorough and taking into account every single bit of energy consumed and practicality.
Yeah, makes sense. Yes. It's quite interesting to see that the Act really calls out a number of things that need to be measured in some way, and yet we haven't really agreed upon how to measure those things yet. So I guess it's really pointing some it's pointing some interesting gaps that are certainly going to have to be filled, given what's been called out.
Yes, I think to add to that, what's very relevant to know is that the EU has established this AI office, and they are really seeking collaboration with practitioners and researchers to develop such guidelines, right? So to really find a balance between every nitty-gritty detail, if you will, and the practicality of those approaches. Yeah, so I think there will be a lot of discussion also publicly going on over the next couple of months.
Great. Well, I don't see any other questions out there, and also we're running a bit low on time. So again, thank you so much for sharing this piece of work with us. And I understand, is it on this on archive yet? This position paper?
We're waiting for the link. So it got put on hold. Whatever filter we ran into, I don't know. But I'm sure we can make it available on YouTube in the YouTube comments box once it's available.
Excellent stuff. Again, well, thank you very much for sharing.